The most important ratio that we have learned so far is the slope ratio. And slope is represented as delta y over delta x. That is the change in y divided by the change in x, or more informally, rise over run. If we decide to focus on this base angle, this non-right base angle, another name for the slope ratio is the tangent ratio. So for part A, we're going to draw a slope triangle and then label the slope ratio and the tangent ratio. To draw a slope triangle, you need to find two intersection points where the line intersects with the grid marks. I see one here, and I see one here. So I'm going to build a slope triangle, which is always a right triangle as well. And the rise, the change in the y values is 1 unit, and the change in the x values is 2 units. So the slope ratio is delta y over delta x, change in y over change in x. And the tangent ratio of this acute base angle is also 1/2. Draw a slope triangle for the line in part B. I only see 2 intersection points. Our change in y is 9 units. Our change in x is 5 units. So our slope ratio, rise over run, is 9/5, and our tangent ratio is also 9/5 when we are focusing on this angle. Will it topple? The Leaning Tower of Pisa is expected to collapse once its angle of slant is less than 83 degrees. Currently, the top of the 7th story, or point A in the diagram at right, is 50 meters above the ground. In addition, when a weight is dropped from point A, it lands 5 meters from the base of the tower, as shown in the diagram. What is the slope ratio for the tower? We are focusing on this lower left angle, and so our slope ratio, also known as the tangent ratio, would be rise over run, the change in y over the change in x. If you can ever reduce your slope, you should. So the slope ratio for the Tower of Pisa is 10. We'll find out if it'll topple later in this chapter. Find the tangent ratio for the triangles below. We're looking at this acute base angle, and so the change in y over the change in x. So our slope ratio, or tangent ratio, is delta y over delta x, 32/24. And if you can reduce, you should. I believe 8 goes into both of these. 8 goes into 32 4 times, and 8 goes into 24 3 times. So the tangent ratio for angle C is 4/3. Now the tangent ratio for angle X. We're looking at the base angle. This one? No, we're looking at the non-right base angle, so the acute angle. So delta y would be the change in the height, the rise, and delta x would be the run, the change in x. So our tangent ratio here is rise over run, 12/16, which also reduces. 4 is a factor of each, so divide them by 4. And we have our tangent ratio for the angle x. But sometimes the triangles are not oriented in a way where it's easy for us to see the rise and the run, or the change in y and the change in x, such as these triangles here. So what we do is we label the sides according to the angle. So they're going to give you an angle to focus on, and the sides are all labeled according to that focus angle. The Greek letter theta, which looks like a 0 with a horizontal line through it, is a variable used for angles. So sometimes we will call this angle angle C, but sometimes there may be a variable representing the unknown angle, and that is often theta. So we're going to practice labeling the sides according to the angle. All right, so if theta is right here, we have the hypotenuse, which is always opposite the right angle. It does not touch the right angle. The hypotenuse does not touch the right angle. And the hypotenuse of every triangle is the same no matter which angle is your focus angle. The hypotenuse does not touch the right angle. But now we have two other sides. We have the opposite side, which is the side literally opposite from theta. It does not touch the focus angle of theta. And then the last side we do need to label is the adjacent side. This side touches both theta and the right angle. Focus on angle C. So I am going to circle angle C and label the sides according to that angle. Always, let's label the hypotenuse first. The hypotenuse is the side that does not touch the right angle. Opposite the right angle is the hypotenuse. The opposite side is opposite our focus angle, so opposite angle C. I'm going to write OPP for opposite. The adjacent side touches both our focus angle C and our right angle B. So this right here is our adjacent side. And I'll write ADJ. All right, time to try with your focus angle A. Label your sides. The hypotenuse does not touch the right angle. The opposite side is opposite theta, does not touch theta. The adjacent side touches both theta and the right angle. The ratio of triangle side lengths is very important in trigonometry. Each trigonometric function corresponds with a specific ratio of sides. Why do we care about right triangles so much? Well, pretty much every shape that we have can be made up of a bunch of right triangles. And so if we can know everything there is to know about a right triangle, and then I can build anything out of right triangles, then I can know everything I need to know about anything. Well, maybe not exactly. The first trigonometric ratio that we have talked about so far is tangent, but we also have two others. The trigonometric function that corresponds with the opposite side and the hypotenuse is called sine. The way we write it mathematically is SIN, and since the focus angle is theta, we write theta here. Be very careful. This is not sine times theta. This is sine of theta. That means sine is something you're doing to the theta. You are taking the sine of theta. Just like you can't have an empty square root, you can't just have a sine hanging out with nothing that you're taking the sine of. The trigonometric function that corresponds to our adjacent side and our hypotenuse is called cosine. The abbreviation is COS, and to refer to that base angle, we would say the cosine of theta. And as we mentioned before, the ratio that cares about your height over your base or your opposite and adjacent sides is the tangent ratio. The abbreviation is TAN of theta, tan theta, tangent theta. Even though mathematically we write them as abbreviations, it is important to say them correctly, and almost always I will say them completely. Sometimes I abbreviate tangent to tan, but for the most part we will be using the full name for it. We're learning a lot of strange words: sine, cosine, adjacent. We learned hypotenuse a couple weeks ago. How in the world are you going to remember which trig function goes with which ratio? There's a super famous acronym that we use in geometry to help us remember which trig function corresponds with which ratio of sides. The sine trig function corresponds to the opposite over the hypotenuse. The cosine trig function corresponds with the adjacent side over the hypotenuse. And the tangent trig function corresponds with the opposite side over the adjacent. Some people prefer to write it like this to remind themselves of the ratio or the fraction, which is the numerator and which is the denominator. But either way, here we have the super famous acronym SOH. SOH. And we use it all the time to help us know which trig function corresponds to which ratio of sides. All right. First, we're going to find sine of theta. All right. My focus angle is theta. So I'm going to circle my focus angle and label my sides. Circle your angle and label your sides. Always, always, always. The hypotenuse is across from our right angle. The opposite side is opposite or across from theta. And the adjacent side touches both theta and the right angle. Now that we've labeled our sides, we can find out what the ratio is. Sine of theta, well, that corresponds to the opposite side over the hypotenuse. Sine theta equals opposite, which is 6, over hypotenuse, which is 10. If you can reduce it, you definitely should. So sine of theta is equal to, divide each by 2. Sine of theta equals 3 over 5. Now we're going to find cosine of theta. Circle your angle and label your sides. The hypotenuse is opposite the right angle. The opposite side does not touch theta, is opposite theta. And the adjacent side touches both theta and the right angle. Oh, look, it's the exact same triangle we had before. So we look at cosine of theta and see that it corresponds to the adjacent side over the hypotenuse. So we'll write cosine of theta, COS, and then the theta symbol is equal to the adjacent side, which is 8, over the hypotenuse, which is 10. If you can reduce it, you absolutely need to. So cosine of theta is equal to, divide each of those by 2, and we get 4 over 5. Tangent of theta is equal to the opposite side over the adjacent side, so 6 over 8. So tangent of theta reduces to be 3 over 4. In order to find your focus angle, you will find the indicated trigonometric ratio of the angle shown. Okay, this one right here is telling us to focus on angle C. So we're going to circle angle C and label all the sides according to angle C. Now the hypotenuse is always across from, does not touch the right angle. The opposite side is always across from, does not touch the focus angle. And the adjacent side always touches both theta, both our focus angle and our right angle. So sine of C, our focus angle, is the opposite over the hypotenuse. And since we've labeled it correctly, sine of C is equal to 3 over 5. Can we reduce that? No. So we're done. Try parts B and C on your own. Cosine of Z is the adjacent side, which is 4, over the hypotenuse, which is 5. That's fully reduced. Tangent of C, I've labeled my sides. Tangent is the opposite over the adjacent, so 18 over 24. I know that at least 2 goes into each of those. Is there a bigger number? Each of these has a factor of 6, so that reduces to be 3 over 4. Tangent of C is 3 over 4. Go ahead and complete the rest and then click continue when you're ready to check your answers. Don't forget to circle your focus angle and label your sides. Go ahead and check your answers. Just remember the acronym SOH TOA can help you remember which trig function corresponds to which ratio of sides.